So, as Tim said, I am Liz. You might have come across me from events like KubeCon. I've been involved in the CNCF for a long time. I've written some books about containers and about eBPF, which is technology that I will be talking about a bit today. We're going to be giving away some copies of the What is eBPF booklet at lunchtime today. So if you want to pick up one of those after the talk, do come and do that and say hello. We have an Isovalent booth out there. Isovalent was acquired by Cisco earlier in the year, so we're now part of the Cisco family as well. And yeah, I'm going to be talking about one of the Cilium sub-projects called Tetragon. How many people here have used Cilium? Okay, quite a good show of hands. Lots of people have used Cilium, and it's probably best known for eBPF-based Kubernetes networking, so very highly performant and secure networking in Kubernetes deployments. Also within the Cilium project, there's the Hubble observability component, which gives us observability into network traffic. And then what I'm going to talk about today, which is Tetragon. And this is, I mean, it's been there for a couple of years now, but it's the newest member of the Cilium family. It's giving us runtime security, observability, and enforcement. And all of these components of Cilium are built on this amazing kernel technology called eBPF. How many people here have come across eBPF before? Also, lots of hands. That's great. So eBPF allows us to customize the way that the kernel behaves. We can write programs, load them into the kernel, attach them to events, and change the way that the kernel responds to events. And this is important because our applications are using the kernel all the time. If we're writing application code, we don't normally have to think about the kernel, we don't have to think about system calls. But in reality, every time our applications access a file or send or receive a network message, they're allocating memory, all of these operations require assistance from the kernel. And the kernel is also coordinating all the different applications that are running on a given machine or virtual machine. So we can attach eBPF programs to lots of different types of events that might be to do with accessing files or network messages or memory or privilege escalation or all sorts of different things that are happening within the kernel. And we can use our eBPF programs to observe the fact that those events are happening or even modify the way that the kernel responds to those events. And that is particularly useful if we want to build security tools, because security is often interested in things like malicious file access or unexpected network connections or unexpected privilege changes or exploring different privileges and capabilities. So we can build some really powerful tools using eBPF that can observe these security-relevant events and maybe even prevent those events from happening. So Tetragon is this sub-project of Cilium. Everything I'm going to show you here is open source, so you can take this from GitHub and run everything yourself. I'll talk a little bit more later on about the kind of in-kernel filtering and what makes Tetragon unique. Tetragon is also designed to be used in Kubernetes or outside of Kubernetes. And since this is ContainerDays rather than KubeCon, I thought I will show you Tetragon running in just regular Docker containers. You can use it directly on a Linux host as well, so it can be used standalone with or without Kubernetes. So I think it's time that we get to a demo, because who doesn't want to see a demo? And of course, my connection has gone, so I'm going to have to reopen my connections. Let's hope I can. Oh, what's happened to the Wi-Fi? Come on. This is if okay. We'll give the Wi-Fi a second to see if it comes back and I can do this. Hopefully, It's live demos, right? OK, we seem to be in some kind of luck. Let's see whether that one's alive. And is this one alive? OK, both my windows are alive. Good. All right, so I've got a couple of containers running right now. I've got Tetragon. The easiest way to deploy Tetragon on a machine is to run this containerized image, so that's what I'm doing. It's a privileged container, and it's able to observe everything that's happening on this virtual machine. I've also got this XZ backdoor. We'll come to that later. The other thing I wanted to show you is that I have a couple of aliases set up just to make my life easier in this demo. Is this big enough to read, by the way? Can you see it OK? Lots of thumbs up, excellent. Yeah, so I'm going to be typing things like DT and DX so that I can execute commands inside my running containers. So the first thing I'm going to do is start the stream of events from Tetragon. Oops, and if I can type the word events, that would be good. And there's a nice human-readable form of events that Tetragon can output. And if I do things on the same virtual machine, we should see some events being emitted. So by default, without any policies applied, Tetragon is going to show us when any executable starts and when it exits. And let's do another one. We'll do PS, for example. And we can see we're getting a little bit of information here about what command I'm running. Now, this is just the human-readable form, so I'm going to just show you the JSON that backs this. I think I'll do it like this. So I'm just going to pipe it into jQuery with a bit of buffer formatting. OK, so if I look at those events, we should see exactly the same as what we just saw, the kind of compact human readable output. We've got a process starting event here, and then we've got a process exit event. And the thing I wanted to show is that we get information about the process. We're getting not just things like the process ID, the user ID, the actual executable that's being run. We've got things like the start time here. But we've also got some information about the parent process. And the reason why that's useful will become clear later when we want to think about building up a process hierarchy to show how one process has spawned another. So behind all the human-readable output that I'm going to show today, there is this much richer JSON. But it's quite hard to read, so I will go back to just using the human-readable compact output. OK, so now I want to add a policy, and I've got them stored. I need to just check what it's called. OK, file monitoring, that's what I want to do. So I'm going to add this file monitoring policy. And what this is going to do, or maybe it already exists. Let's have a look. OK, it's already there. So what this policy is going to do is report access to a set of files that we think are sensitive. I can show you the kind of files that we need. The policy is actually quite complex, so I won't go through everything in here, but we can see here are a set of files that we think are sensitive, things like .ssh, profile, and so on. But not just the ones in etc. directory, also any file that ends in, say, .bashrc and .profile and .login. There's a whole set of different files that we're monitoring access to using this policy. And so if I take a look at a not sensitive file, what we should see is the default process entry and exit for the fact that we ran cat on that not sensitive file. But if I want to take a look at my .profile file, this is a sensitive. At the same time as I'm doing it, there's some systemd logging going on that has also triggered my events. So here we go with the process entry to outputting my profile, but also a couple of read events here. I don't know if it shows up too well if I highlight it, but a couple of read events as well as the process entry and exit. So we've created a profile that gives us extra logs when we do this access to a sensitive file. So we've seen we can get compact output, we get default entry and exit logs for, or events triggered by, or emitted by Tetragon every time we run a process. We've got this hierarchical information about not just the process itself, but also its parent. And we can create a policy to output additional events for specific things that we're interested in. In this case, it was accessing sensitive files. But there are lots and lots of other types of events that we can write policies for using Tetragon. We can write policies to detect things like not just accessing files, but maybe accessing particular network destinations. We can monitor for things like namespace changes or privilege escalations that might be interesting from a security point of view. And, as we'll see, we can use Tetragon and write policies to help us detect specific zero-day vulnerabilities. So what is a zero-day vulnerability? It's essentially a newly discovered vulnerability. Usually it's a bug in a package that allows that package to be abused, that allows an attacker to do something bad on your system. And typically, the first we hear about it is that there's a CVE, Common Vulnerability Enumerator, information about this vulnerability that gets published. And it will include things like a brief description of what the vulnerability is. It will tell you how serious it is. And it will tell you what packages and what versions of those packages are affected. Most of the time, there's also, by the time a vulnerability is published, there's also a fixed version. So you want to be able to update from your affected version to the fixed version. And there is lots of great tooling out there to help you identify at build time whether or not you're running vulnerable packages that have known vulnerabilities in them and can help you rebuild your images. But there's a limit to what build time tooling is going to tell you. And what build time tooling won't tell you is whether or not you're actually running images in your deployment that have these affected libraries. It can tell you whether you've built them, but it can't tell you whether they're running. And it certainly can't tell you whether or not you've been exploited or whether there is an ongoing exploitation of your live system. Just because a vulnerability exists doesn't necessarily mean that you and your deployment is being attacked right now. So a lot of the time, security people are making a decision about how risky it is and how quickly they need to rebuild the affected images and redeploy them. And when they redeploy them, is there going to be some downtime? Do we need to have a period of time where we test the fixed version of that package and make sure that it works well with our applications? What we can do at runtime using Tetragon is help to answer those questions. We can use Tetragon to figure out whether or not that vulnerable version of a package is running anywhere in our system. And we can also use Tetragon to look for specific bad behaviors. We can block those bad behaviors if we so choose. And because we've got all this rich information about the events that we're looking for, we can potentially understand when and how we got compromised if we discover that we have actually been exploited. So this is a pretty famous vulnerability that was discovered in 2024, XZ Utils vulnerability. And you might have heard about this one in the news because the person who put this vulnerability in spent 2 years working on the Utils project, getting credibility, getting maintainer status on that project. And all the time they were doing that, they spent over 2 years with the goal of putting this backdoor into Utils. And the backdoor is really very serious. It allows for, when Utils is used as part of SSH authentication, it allows for remote code execution. And this is like the worst nightmare for a security person, right? That somebody can remotely execute arbitrary commands in your system. So the particular versions that are affected are this liblzma versions 5.6.0 and 5.6.1. So the most straightforward thing we can do with Tetragon is figure out whether those versions of that library are actually being used in your deployment. Are we accessing that file? And we can write a policy that will detect that particular package, that particular version. I've got a demo here that uses a compromised version of Utils. So shout out to these two GitHub projects, the Resigned, which is a containerized version of this XZbot project from AML Weems. I don't know if that's how they say their handle. Okay, so let's, for some reason my screen's gone a bit dark, but I think I can see it. Okay, let's take a look at that policy first. So I've got Utils YAML file. And basically, this is hooking into a kernel function called security mmap file. This is where we are loading that file or ensuring that that file is loaded into memory so we can execute it. And we're interested in the SSHD executable, loading that file, and it being liblzma version 5.6.0 or 5.6.1. Okay, so that's what the policy looks like, and I'm going to apply that. So tracing policy, add policies, Utils.yaml. So this is just going to detect when that library is being used. So I can now run my exploit. So this is executing into my XZ backdoor container that's running. And I can do something like, well, I can execute any arbitrary command. Let's say echo hello Hamburg into a temporary file in this container. Okay. Now, in the bottom window, we can see, an SSH handshake failed. That's the exploit being used to execute the arbitrary command. And we can actually see in the output from Tetragon, we can see, well, first of all, here's the SSHD process being started. That's being triggered by my XZbot file or executable starting this SSH handshake. Then we can see there's actually 3 events where Tetragon has detected that liblzma 5.6.1 being used. And then we can see the actual arbitrary command being run here. This is a shell command writing hello Hamburg into this temporary file. And we can just take a look to see that that has actually happened. So I can do cat of that file, and we can see, yeah, my arbitrary command was indeed executed. And it was detected by Tetragon. We could see those events being generated saying, yeah, we are using that 5.6.1 library. This is potentially a problem. So you can imagine sending those logs to something that looks for that particular, or the JSON, probably not the human-readable output, probably the JSON version, and says, OK, I can see that library is being used. And I can see what machine it's being run on, I can see what container it's being run in, and so on and so forth. So now let's see what happens if we choose to block that event. So I've got a different policy. So I want to compare XE-Utils and block XE-Utils. And basically, aside from the name, the difference is that instead of just posting events, I'm going to kill, using sig kill, any process that attempts to use that library. So I need to disable, actually let's just look at the policies first. So I'm going to disable the current policy, disable CVE 2024, 3094. I don't know why I've given it such a long name. That was silly. OK, and instead of that one, I'm going to add the block version. Let me just check that name again. OK, so add policies, block XE utils.yaml. OK, so now I've got a policy that should prevent that library from being used. So if I try to do basically the same command as I did before, here we go. Instead of saying hello, Hamburg, I'll say hello again, Hamburg. OK, and we see some different output. First of all, the SSH handshake failed, but in a different way from how it failed before. But if we look in the Tetragon output, what we can see is the SSHD command was started, or process was started again as before. And then we can see the 5.6.1 version of liblDMA being mapped into memory. And that has been followed by killing the SSHD process that was attempting to run it. So if we take a look at that temporary file, where's it gone? Is it going? It would have been quicker for me to just type it in. There we go. Still just says hello Hamburg. It doesn't say hello again Hamburg. We prevented that exploit from being run. We prevented, or the Tetragon policy prevented the arbitrary command from being run in my container, which is pretty cool, right? Thank you. All right. Awesome. So by default, we would have seen events being generated that showed the remote execution. So if before that zero-day vulnerability was published, if we were sending these events to some kind of SIM or some kind of log, we'd be able to go back and look to see what processes had been potentially executed unexpectedly, like a shell command. We can use the policy to detect the use of a vulnerable package. And you could use that template to, you could use that as a basis for detecting any version of any library that in future is determined to be a problem. And we have the option to kill the parent process that's using that exploit. So that can be a powerful way to mitigate a vulnerability while you're figuring out how to rebuild your images. Or if there is a vulnerability that doesn't yet have a patch, you can at least protect yourself from being attacked using that remote code execution vulnerability. So yeah, as I say, you could use that example, which is on GitHub. You can modify that version to protect against any future zero-day. Now, you might be wondering, and it would be perfectly reasonable to wonder, if I'm monitoring all these events, isn't that going to create a large amount of overhead on my system? And the reality is, it's super fast. eBPF, because it's running in the kernel and doesn't require lots of context switching between kernel and user space, is generally pretty high performance anyway. But the thing that we do in Tetragon that is unique and kind of a step forward compared to some other eBPF-based security tooling is that we filter events in the kernel. So up until Tetragon, there have been tools that collect events in the kernel, send those events to user space, and then compare them against a policy in user space. So all that kind of evaluating events against a policy and determining whether there is something we need to be telling the user about happens in user space. But with Tetragon, we're actually evaluating the events against the policy in the kernel. So we're only sending a subset of events that are potentially malicious to user space. So, for example, if you were using that file monitoring policy to look at sensitive file access, we're not generating events every single time you access a file. We're only generating events to user space if they are one of those sensitive files that we'd put into the policy. And the fact that there's a much, much smaller number of events being generated really helps to improve performance and reduce the overhead. So we've got a couple of benchmarks that we've done to evaluate that overhead. This example is building a kernel and generating, I think this was file read events. During that build process, there are 1.5 million events being generated during that build, and you can see less than 2% overhead by monitoring those events using Tetragon. Another benchmark that we had was essentially doing a lot of file reads with multiple threads. So the green bar here is with no monitoring at all. The yellow bar is monitoring with Tetragon, and the blue bar is monitoring with, it says traditional solution. It is another eBPF-based security open source project. So really very, very marginal overhead. In this case, more like 0.2% rather than less than 2%. So with the right policies, you can get incredibly detailed and incredibly rich and incredibly helpful security information without imposing a lot of overhead on your system. You can use that, you can generate those events on any Linux machine. It will detect events whether they're running inside containers or directly on the host or inside Kubernetes pods. And we might want to use the event logs that have been generated to understand whether in the past we have been exploited. So we can send all these rich JSON event information. What I showed you before is just running on a host, so there obviously wasn't any Kubernetes information. But you can see here that if we are running in Kubernetes, you start getting information about the pod that a process is running in. So we're getting pod labels, the namespace, information about the container, information about when that container was started, and so on. We get lots of capabilities and privilege information. So these really rich JSON informations can be used to build up a picture of how a process hierarchy is built up. So an executable might have been spawned by another executable, which was spawned by another executable, which was running inside a container, which was spawned by container D, and go back all the way to system D, let's say. And you can build up all this information from that JSON event, the event logs. So if you are running in Kubernetes, you're going to have the ability to find out if something unexpected happens, like an unexpected shell command being run, You'll know what namespace it was running in, what pod it was running in. You can see the fact that it was running inside the container. You can see the pod process tree. You can see when that executable was started. You can see when that container was started. All that forensic information might help you to understand how the container got compromised in the first place. How long has that compromised container been running in your deployment? So you can use a SIM of your choice. You can send that event to, S3 or a database of your choice, a time series database of your choice, and use whatever queries you want to over those tools to understand the event history that's happened on your machine. So I just want to finish up with a nice quote from Jason at GitHub, who's been one of the kind of early adopters, I would say, of Tetragon, talking about how Tetragon provides the security teams with rich data that connects important network, process, and Kubernetes metadata into event records that allow them to answer questions about activity on their clusters. That it's quick to set up, minimal overhead, and critical when you're running at scale. So that's everything that I wanted to show. I think I've got a few more minutes for questions, so I hope there are some questions. Get in there and type in some questions. We also have a booth outside, the Isovalent booth. There will be some more Tetragon demos and also Cilium demos happening at the booth. Going to be signing those What is eBPF books at lunchtime, so come and say hello there. There are also loads of online resources, tetragon.io, if you want to find out more about Tetragon. We've got some hands-on labs on the Isovalent site where you can try out Tetragon there. And I also wanted to mention the eBPF Summit, which is happening a week tomorrow, so Wednesday the 11th. It's online, it's free to attend, and if you're interested in eBPF, there'll be lots of really great talks to learn about eBPF from that. So with that, the demo gods were just about with me, I think. I hope you've got lots of questions.
The first question, and they are moderated, so I do have to accept the questions just in case, engineers. It's similar to Tetragon. I'm kind of making sure that the right questions are coming in. So the first question is, how is Tetragon different from Falco?
Sure, OK. So Falco has two modes. One is a kernel module mode, and one is eBPF-based. Both those approaches allow, very similar to Tetragon, the ability to detect events that are happening inside the kernel. I would certainly prefer to use eBPF rather than a kernel module just for safety, because eBPF will verify that that code is safe to run. So that would be one preference. The other big difference is that Tetragon's doing that in kernel filtering. So we're emitting fewer events, and so that should lead to lower overhead and better performance.
Thank you. Next one is the killing of the process synchronous? That's
a great question. Yes, it is. So it requires, I can't remember from exactly what kernel version it is, but there's a kernel version, a minimum kernel version, from which we can send a kill signal from within the kernel to kill the process synchronously. Yes.
They're coming in. Do I have to install Tetragon? Oh. On every pod, I'll take.
I think I saw that.
One. Yeah.
Yeah. No, you don't, because Tetragon's running in the kernel, and there is one kernel on a virtual machine. However many containers you're running, they all share the same kernel. So Tetragon in Kubernetes is typically deployed as a daemon set. So you have got an instance of it running on every node, but you just install it as a daemon set. You don't have to think about that. And one of the really great things about eBPF is, as soon as you install it, it can see events, not just from new pods, but from pre-existing pods, pre-existing processes. It doesn't matter whether the process was already running or not, it's visible to eBPF.
Yeah, so no sidecars needed.
No sidecars needed, yeah.
I'll keep that up. Is there a repository for policies? As this is probably the most effort setting up all the policies to detect malicious behavior. Obviously, engineers trying to find a...
Sure, yeah. I mean, it is true that writing policies does require a certain amount of kernel knowledge, unless you can find a pattern like that XE Utils example. You could use that as a pattern, and I think a lot of people would be able to, copy and modify that to detect different libraries and different version numbers. Yes, there is an examples directory inside the Tetragon repo. I'm not going to say that it's necessarily just under example. I think it's under examples. There is definitely an examples repo there, or examples directory there. Yeah.
Cool. I'm not sure if we'll be able to go through all of them, but we'll try. So 0-day drops right now. How do you handle it with Tetragon?
So they're going to publish what the library is, what name of the library is, and what affected versions are. We're going to copy that policy. We're going to update it with the name of that library, the names, the version numbers that are affected. We're going to apply that policy to our Tetragon deployments, and we will know whether or not we're running that affected library. In parallel, we're probably also running image scanning. We're running rebuilds if there's a patched version of those images, but it helps us to prioritize, how important this is, how critical it is to get those rebuilt images deployed.
Yeah, and a fix for any CV does take a while, so it's actually quite nice to have a way to stop any attacks.
Yeah.
I'm sure Log4j issue would have been nice to have there.
Yeah.
Remember everybody getting on and trying to solve it. Next one is, you mentioned that only processes that are suspicious are being logged, monitored. How is it decided which ones fall into this category?
Okay, so all process executions and exits are being monitored, or being logged, in fact, by default. But it was files that we decided were sensitive that, we've just written a policy that, maybe says everything that's inside the etc. directory and everything that involves, passwords, that kind of thing. Yeah.
I'll take a few more, but then please do reach out to Liz at the booth. Other trustable options to get new policies based on new CVEs?
So I think there's an interesting part of that question is trustable. Because you could write a policy that blocks, you could essentially sort of DDoS yourself by writing a bad policy. Yeah. I would hope that, as a, I would like to think of Tetragon as a well-run project that would not just randomly accept any old policy without thinking about it. But yeah, don't just download any policy off the internet and run it, because it might not have the effect that you...
Okay, I'll take the last two. You can vote for the questions you want on the app as well, so the highest ones will get there. Can I use Tetragon when I'm using a managed Kubernetes cluster with no access to the control plane? Does the daemon set install work then?
This is a really great question. So the answer is kind of, it depends. If you can deploy a privileged pod, Tetragon needs a certain number of privileges in order to be able to, well, A, load BPF code in the first place. That requires a cat BPF privilege. And having visibility over everything that's running on a machine requires privileges. So it really depends whether your managed cluster allows you to deploy privileged pods or not.
Yeah, and there are some cloud providers, I believe, nowadays that come with eBPF and Tetragon, I believe, also pre-installed.
So I'm not actually aware whether Tetragon's pre-installed, but there are certainly, we have good relationships with all the cloud providers, and certainly making this kind of thing, things like Cilium and Tetragon, easy to use and install is something that we're working very closely with the cloud providers on. Yeah.
Okay. I'll take the last one, and that is storage size for logs a big problem in production? Can you give some pointers on how to minimize that?
I would basically punt that question and say, Tetragon generates the logs. It will generate as many events as you have policies to generate. So, you have some, balancing acts there to do with how many events you want to generate. And then it really depends on your, whether you're using a SIM, whether you're going to send those events to an S3 bucket, how you're going to handle those events. If you're going to run some processing directly on the host there and then, I probably wouldn't recommend that. So for example, a lot of our customers might use something like Splunk, export all the data there, and then they can do fancy queries to understand what's going on in Splunk.
Yeah, I think it's also a learning process as well. You start to understand what logs you actually need, what not, so the retention period, so on and so forth.
Yes.
Okay, I did say that was going to be the last one, but we do have one more. What actions are possible?
So I guess this is the question of, I can report an event or I can kill the process. As far as I know, that's essentially the two actions that are possible. There are also the ability to rate limit the if you're getting a lot of instances of the same event being generated, that can be rate limited. I think right now that's the full extent of actions that are possible. But, Tetragon is a live and evolving project. So if you have ideas for other actions, then, come and have a chat. And
open sourced as well.
Absolutely.
So get involved. Okay, I'm going to cut it short because questions do keep on coming.
There are lots.
We can keep.
Thank you for the questions.
That's great. But also Liz is here. As she said, Isovalent do have a booth. Do go and see them. I think there's going to be a demo as well in the booth section. And obviously, do get the book because Liz is here. One last round of applause for Liz. Thank you.
Thank you so much. Great.